Hello guys and welcome back. So now we have the source cache to disk, and all the data that we need for the whitewater solver to work is these points and the original mesh. So I'm gonna create a null output and call this out volumes. As this is the original sim, and I'm gonna call this out whitewater source. Okay, let's create a dot network. I'm going to call this sim whitewater. And let's dive inside. We need a whitewater emitter. We need a whitewater object. And we need a whitewater solver. And this is how the connection is going to be. First of all, the initialization of the data, and then the emission, and then we need a merge node to start introducing some of the collision meshes that we had before, and we'll do that in a bit. But basically, what we need to feed this as well is the collision geometry that we had from the sim. Now let's set this up to so that it functions, and then we're going to copy the collision objects from the flip sim. So the main thing is the source object, and this is going to be the whitewater source. Okay, and then under the second input is going to be in the whitewater solver under the, let's say, under the volume source. So this is going to be the out volume. Now this is not all the data needed. This guy needs a domain because it's gonna create something similar to the smoke sim. We need the information from the flip sim. So let's go back up, disable any cooking. And here I'm gonna dive inside, and I'm gonna make a floating tab of this, and this is what I'm interested in. This is the information I want. I'm gonna say always on top, and I'm gonna copy all this section. We may have to change the path. No, I think it's good. I'm gonna copy this, go back to the whitewater, and let's paste this. Make sure the left input is first, and we want these values to be the same. So I'm going to copy this, paste relative reference, copy this, paste relative reference. Okay, and I think that's it. I want to make sure we have caching. I want to cache a couple of frames, and for now we didn't change anything. Everything is enabled: bubble, foam, and spray. And it's going. Let's zoom in. I'm going to hide all these guys from the viewport, and let's check something. So right now the emission berth is set to 100, which is quite high, so I'm gonna set this to 10 for now, and then we'll increase it for the final when we go to the high-res sim. But 80 is what I've used in the final sim. Unfortunately, this is not a precise value, so you always have to do one sim at a specific value, let's say 20 for example, and then based on that you say, okay, I've got 10 million points using 20 and I need 80 million for example, so you multiply that 20 by 4 and you use 80, and that should give you approximately 80 million. It's a linear increase, but you have to do one sim at using one setting to know exactly what's going to happen. Cool, so everything looks like is working. And what I'd like to do is I want to use show different colors for the foam, spray, and bubble. And I'm gonna take this on, and this should change the color of the points, and we know which is which basically. And it's not always that you need the bubble, the spray, and the foam. I think most of the time you need foam for sure, but the bubble is not something that you need all the time, especially if the water is too dark, or if you don't see through it too much, like an ocean for example. You don't see a lot underneath. It's mostly what's at the upper surface, so it may not always make sense to have the bubble sim. Now what's happening here is when if the bubble is emitted underneath, as it gets up to the surface, some of them will die, but some of them will make it through, and those will be converted into a foam as they get advected. So that's gonna increase the amount of foam as well if you have bubble on. And these are the spray. Cool. Okay, so what I'm going to do is I'm going to tweak a few things in the sim. So for the foam, I'm going to lower the depth a bit. You remember we use -1 and -0.1 and 0.1, and that was enough to capture these guys, so basically 10 centimeter. I'm going to lower this to 1.5, 0015. And then I'm going to increase the lifespan. I want the foam to drag longer, for a bit longer. So I'm going to set this to 3 and 1. I'm going to increase the lifespan variance between the two. Now, another thing that I like to do, by default the foam dies quickly, and we can keep it on for a bit longer by using this option called preserve foam. And if the density of the foam is between this range, it's going to have a higher rate of living longer, which could be interesting, especially that the sim is a small scale and everything is happening in a localized space. So I'm going to set this to between 5 and 80 to double basically the range, and then the preservation rate is 0.5 and the reduction rate is 0.25. Now obviously these are settings that I've run a couple of tests to get to, and I highly encourage you guys to do a couple of wedges. You can start by having these two guys off and just focus on one of them. Do a version without the preserve foam on, and do a version with the default preserve foam, and then do a version with a preserve foam custom settings. Let's say 5 and 100 and 0.5 and 0.25 here, or 1 here, and stuff like that. So try to explore with these guys. I don't have a magic formula. Each scene has different requirements, and I always end up doing different settings here. So for the advection strength, I'm going to lower this to 150 instead of 50,000, which is quite high. And I'm going to leave this is a new feature in Houdini 16.5, I think, that's going to help with the creating a froth foam, but our scene scale is quite small. As you can see, 0.1 is 10 centimeter, so I'm going to lower this to 0.2, and I'm going to lower this to 1.5 as well, and I'm going to leave the other two to the defaults. So this is for the foam. For the spray, I'm gonna I'm gonna tick on speed limit. I don't want anything to go beyond the speed of 10. I don't like to have spray at all in the scene because we don't have any big splashes, but with this it's gonna keep them quiet and calm, and that's what I'm looking for. Now the bubble is something very, very tricky and dangerous to turn on, because as you saw, we have a thin layer of foam at the upper level, and then we have an emission rate of 10. But the bubble emitter is much thicker, and you can see they're covering a much higher depth, much bigger depth. Now, if we're gonna increase this to 100, it's gonna say make the foam 10 times it's going to increase the amount of foam, the point foam, and also it's going to increase the bubble. And most of the time you're going to end up with, let's say, 5 million foam and 20 million bubbles, and that's not something you would want to happen. So you have to be careful how much bubble you have in your scene. It's not always a good idea to turn it on, to be honest. But yeah, so I'm gonna set this to 3, and then the advection strength to 3 as well, because what's happening underneath is not too strong. So I'm gonna lower that a tiny bit, and I think that's pretty much it. We don't have any closed boundaries, so I'm gonna turn this off. We could add a pop drag as well on top of this. And we can add it here or in the velocity update. Yeah, particle force, that should be fine. Any input is fine, to be honest. I'm gonna set this to 0.1. And we have our collision geometry. And I'm gonna leave this to 10 for now. Okay, and I'm going to run a few frames, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.